Hello everybody, welcome into another lesson. So today we are going to do part 2 of solving trigonometric equations. Today's lesson will be about multiple angles. So what does that mean by multiple angles? If you have a trig function of anything other than 1x or anything other than a 1 as your coefficient of the x, or the variable you're taking the trig function of, that's considered a multiple angle. So you have the cosine of x over 4 is equal to 0. So how are you going to approach that? My suggestion is to be what's called do a u substitution. So we are going to let u equal x over 4. So you can temporarily make this the cosine of u equals 0. You will temporarily just make this a single angle. Now, what angles in the interval of 0 to 2 pi give us a cosine of 0? Well, that's going to be pi over 2 and 3 pi over 2, right? U would equal pi over 2 and 3 pi over 2. Which, in all honesty, if we did pi over 2 plus pi, it would account for 3 pi over 2. So you would end up having pi over 2 plus n pi. If you did pi over 2 plus n pi for your u, you would get every single interval from 0 to 2 pi and any other intervals from negative infinity to infinity where you get a cosine of 0. But that's for u. We're still not done yet. Now you have to take your u once you've got your general solution and put in that x plus 4 for u. So this would mean that x over 4 is what I meant to say would equal pi over 2 plus n pi. Alright, then we just solve for x, so multiply both sides by 4. You would end up getting that x would equal, so 4 times pi over 2 would be 2 pi, plus that n pi, you multiply that by 4, that'd be plus 4n pi. And then, of course, we want to check for extraneous solutions. So, if I take this 2 pi plus 4n pi, then if I put that in for x, I would end up getting pi over 2 plus n pi. So we know that that works. So the general solution in this case is going to be x equals 2 pi plus 4n pi. And I got more. I have 11 total problems today, so not quite as extensive as yesterday, but we still got some problems to work on. We're starting with linear problems again. We'll have a couple factored ones and even a couple quadratic ones at the end. Alright, so we are given that the sine of x over 2 equals 0. So the sine of x over 2 equals 0. Well, again, since this is a multiple angle, I would do a u substitution. So we'll let u equal x over 2. So this would end up becoming the sine of u equals 0. What angles in the interval from 0 to 2 pi give you 0, a sine of 0? Well, that would be 0 and pi, right? So u would equal 0 and pi. Now, if you just take the 0 and add pi into it, you can literally just end up getting u equals n pi. Any integer multiple of pi will give you a sine of 0. But in the end, we're not done yet. We got to take that u, put x over 2 back in for u. So now this turns into x over 2 equals n pi, which would actually end up giving you that x equals 2n pi. And of course we want to check for extraneous solutions. So that n being an integer, of course, any integer multiple of 2 pi, you will end up getting a sign of 0. So the general solution is that x is going to equal 2n pi, 2 times any integer multiple of pi. Alright. So we have here that the sine of 4x is equal to 1. So we have that the sine of 4x equals 1. Okay, so we can let u equal that 4x. So now we can temporarily turn this into the sine of u equals 1. Now, what angle in the interval from 0 to 2 pi will give you a sine of 1? That would just be pi over 2 and only pi over 2. So u would equal pi over 2, and then you'd have to go all the way around again another 2 pi because the period is 2 pi, so it would be pi over 2 plus 2n pi. That would give you every angle from negative infinity to infinity that gives you a sine of 1. But we're not done yet. We got to put that 4x in where u is now. So now you have that 4x is equal to pi over 2 plus 2n pi. Well, to solve for x, just divide both sides by 4. You should end up getting that x equals pi over 8 plus n pi over 2. So let's put in any integer multiple of n. So if I put in pi over 8, let's just put in 0. 4 times pi over 8, that's going to give me pi over 2. Sine of pi over 2 is 1. If I put in 1 for my integer multiple, well, pi over 8 plus pi over 2, that's going to end up being, let's see, that would give me 5 pi over 8, which would turn into 5 pi over 2, which is the same as pi over 2. That's true. So yes, any integer multiple of pi over 2, well, is that true? What if I put in 2 for my integer? Pi over 8 plus pi, what would that give me? That would end up giving me 9 pi over 8, which would end up giving me 9 pi over 2 if I multiplied it. So that would actually be true. Sine of 9 pi over 2 is also 1. So yes, the general solution to this is going to end up being that x equals pi over 8 plus n pi over 2. Okay. I have that the cosine of 2x is equal to negative 1. Alright, so I have the cosine of 2x equals negative 1. So that means we'll let u equal 2x. So let u equal 2x. So this will turn into the cosine of u equals negative 1. Now, what angle in the interval from 0 to 2 pi would give you a value that's a cosine of negative 1? That would be pi, right? U would equal pi, and then cosine has a period of 2 pi, and pi is the only angle in that interval that works, so it would be pi plus 2n pi, any integer multiple of 2 pi after that. However, we're not done yet. We have to put 2x in for where u is, so this would turn into 2x equals pi plus 2n pi, which would end up meaning that x would equal pi over 2 plus n pi. So that would be my final answer, is that x is going to end up equaling pi over 2 plus 2n pi. I'm sorry, pi over 2 plus n pi. All right. We have that the sine of 2x equals negative of the square root of 3 over 2. So we have that the sine of 2x equals negative of the square root of 3 over 2. Well, we can temporarily let u equal 2x. So let's do that. We will let u equal that 2x. So this would turn into the sine of u equals negative of the square root of 3 over 2. Alright, so this is indicating a negative sign. What quadrants give you a negative sign? That's going to be in the third and fourth quadrant. And we're going to start with the interval from 0 to 2 pi. Well, sine is opposite over hypotenuse. If you take the sine of 60, you'll get the square root of 3 over 2. So this is going to be based off of a 60-degree reference angle. 60 degrees, which is pi over 3. Now in the third quadrant, pi over 3 is going to be 4 pi over 3. So u is going to equal 4 pi over 3. And then in the fourth quadrant, it would be 5 pi over 3. And sine has a period of 2 pi, so it would actually start out then being 4 pi over 3 plus 2n pi. And then you'll have again 5 pi over 3 plus 2n pi. However, we're not done yet. We have to put 2x in for where the u was. So now this would turn into 2x is equal to 4 pi over 3 plus 2n pi. And then it would be 5 pi over 3 plus 2n pi. And then divide both sides by 2, you'll have your two general solutions. So that would mean x would equal 4 pi divided by 3. All that divided by 2 would become 2 pi divided by 3 plus n pi. And then that 5 pi divided by 3, well, I'm sorry, that 5 pi divided by 3 divided by 2 is actually going to turn into 5 pi over 6 plus n pi. So those will actually be your two general solutions. X equals 2 pi over 3 plus n pi, and then 5 pi over 6 plus n pi. Alright, I have two more linear ones, then I have two factored ones, then I have two quadratic ones that we're going to work on. I'm sorry, I got three linear ones. Okay. I have the secant of 4x is equal to 2. So I've been given that the secant of 4x equals 2. Well, we'll let u equal 4x temporarily. So let u equal 4x. So we can turn this temporarily into the secant of u equals 2. Well, okay, so this is where the secant's positive. Where is the secant positive? In the first and fourth quadrants. We're going to go in the interval from 0 to 2 pi to start. If we look at our 30, 60, 90 right triangle, we know that secant, of course, is hypotenuse over adjacent. If you take the secant of 60, you would get 2. So that's going to be a pi over 3 reference angle. So u itself would end up equaling pi over 3. And then you're also going to have in the fourth quadrant, that would be the same as 5 pi over 3. So in general, u would equal pi over 3. And then the period of secant is 2 pi. So pi over 3 plus 2n pi. And then again, you'll have 5 pi over 3 plus 2n pi. But now we have to put that 4x in for u, so 4x is going to end up equaling pi over 3 plus 2n pi, and then you'll once again have 5 pi over 3 plus 2n pi, and then just divide both sides by 4, you'll get that x equals pi over 12 plus pi over pi n over 2, or n pi over 2 I should probably say. And then you'll end up getting 5 pi over 12 plus n pi over 2. And let's just check these for extraneous solutions. So 4 times pi over 12, that would give you pi over 3. 4 times 5 pi over 12 gives you 5 pi over 3. Now, let's add a pi over 2 to this, so that would be 7 pi over 12. So that would give you 7 pi over 3, which would turn into pi over 3. If I add, so let's see, add a pi over 2 to that, so that would be 6 pi over 12. I would get 11 pi over 12 times 4 would be 11 pi over 3, which would be 5 pi over 3, so that works. So my two general solutions are going to end up being x equals pi over 12 plus n pi over 2 and 5 pi over 12 plus n pi over 2. Alright, 2 more basic linear ones, then 2 factored, then 2 quadratic, then we're done with the lesson. Alright. We have the cosine of the quantity of x over 2 is going to be equal to the square root of 2 over 2. So the cosine of x over 2 equals the square root of 2 over 2. Well, we can turn that x over 2 temporarily into u. So we'll let u equal x over 2. So we can turn this into the cosine of u equals the square root of 2 over 2. Alright, so now we got to deal with a positive cosine. So once again, where is the cosine positive? Well, the cosine's going to be positive in, that would actually be positive in the first and fourth quadrants. So let's see here. What gives you a cosine of the square root of 2 over 2? Which is, this is the same as 1 over the square root of 2. That'd be 45 degrees, which is pi over 4. So you'd end up having pi over 4 and then 5 pi over 4. So that means then that u, for general solution, would be equal to pi over 4 plus 2n pi, since cosine has a period of 2 pi, and then it would end up being, I say 5 pi over 4, I meant 7 pi over 4, excuse me, because it's in the fourth quadrant, 7 pi over 4. And then you would have 7 pi over 4 plus 2n pi. Well, we got to put that x over 2 in for u now. So x over 2 would equal pi over 4 plus that 2n pi. And then it would be 7 pi over 4 plus 2n pi. Alright, so now let's go ahead and solve for x. To do that, multiply both sides by 2. You'll end up getting x equals pi over 2 plus 4n pi. And then you'll have it again at 7 pi over 2 plus 4n pi. So x would equal pi over 2 plus 4n pi, and then 7 pi over 2 plus 4n pi. All right. Should be one more linear. And let's see, yep, good one. We have the tangent of x over 3 is equal to 1. So we have the tangent of x over 3 is equal to 1. So we'll let u equal the tangent of, we'll just let u equal x over 3 temporarily. So we can turn this into the tangent of u equals 1. Okay, so where do you get a tangent of that's positive? That's going to be in the first and third quadrants. If you look at your 45, 45, 90 right triangle, the tangent of 45 is 1. So in the first quadrant, of course, you'll have u equals pi over 4. And then the third quadrant, that would turn into 5 pi over 4. All right, so in general then, what's the period of the tangent function? Well, it's actually pi. We could write u equals pi over 4 plus n pi, which would actually account for the 5 pi over 4 also. However, we're not done yet. We have to put that x over 3n for u. So x over 3 is going to end up equaling pi over 4 plus n pi, which would then mean that x equals 3 pi over 4 plus 3n pi. So you'll end up getting that x equals 3 pi over 4 plus 3n pi. Let's see, 3 pi over 4 plus 12 pi over 4, it's 15 pi over 4. But would that be accurate though? Let me look at something here. Let's see, plus 3 pi, well that's 12 pi over 4, so 15 pi over 4. That'd be 7 pi over 4, but that wouldn't be accurate because no, that would be accurate. That'd be 5 pi over 4 because you're dividing by 3. Okay. All right, so yes, your general solution is x equals 3 pi over 4 plus 3n pi. All right, so that's it for all the linear ones. Now we're going to do two-factored ones where you have more than one factor involved in this trig equation. Now in these couple, they take it kind of easy on you. You're going to have the tangent of, nope, that's not what I wanted. You'll have the tangent of x minus 1 times the tangent of 3x is equal to 0. So now you have two factors. So again, you're going to take each factor, set it equal to 0. So take that tangent of x minus 1, set that equal to 0, you would get that the tangent of x is equal to 1. Alright, so where does the tangent equal positive 1? That'll be again in the first and third quadrants. So x would start out equaling pi over 4, and then you would have 5 pi over 4. We're not going to do the general solutions just yet. I just wanted to list them for one. Now let's look at the tangent of 3x equals 0. Well, so the tangent of 3x equals 0, we can let u equal 3x. So temporarily, this would be the tangent of u equal to 0. Okay, so where in the interval from 0 to 2 pi does the tangent equal 0? Well, that's going to be at 0 and pi itself. 0 itself and pi. So u would equal 0 and pi. Whoops, not plus pi. Gosh. 0 and pi. Okay, so let's start out here with the left side where we had the tangent of x equal to 1. We definitely have general solutions of, let's see here. So that pi over 4, x would equal pi over 4, and the period of the tangent function is just 1 pi. So if we did pi over 4 plus n pi, we would actually account for the 5 pi over 4. Okay. And then if you want to check for extraneous solutions, so you would end up getting 0 for this factor. It doesn't matter what this one does. You would end up getting 0. So this checks out. This one checks out. Now, what about 0 and pi? Well, first off, we need to know in general that 0 plus pi, because the period of tangent is pi, you could literally just write n pi. Okay? But we'll set that 3x equal to pi, equal to n pi. You should end up getting x equals n pi over 3. You take any integer of n, that would check out, because you would have 1 pi, 2 pi, 3 pi, negative pi, so on. You're always going to get a tangent of 0. So this solution checks out too. So the two general solutions are going to be pi over 4 plus n pi, and then you'll end up having n pi over 3 as your other general solution. So sometimes you could have different forms of general solutions if you have more than one factor. One more factored form, then we got 2 quadratics, then we'll be done with the lesson. Okay. We have 2 times the cosine of x plus 1 times the cosine of 2x. Both of those factors multiplied together equal to 0. Well, let's deal with the first factor, set that equal to 0. So take 2 times the cosine of x plus 1, set that equal to 0. That would give you 2 times the cosine of x equals negative 1, which would give you the cosine of x equals negative 1/2. Alright, so when is the cosine negative? That's in the second and third quadrants. So if we look at our 30, 60, 90 right triangle, the cosine of 60 is 1/2, so we're going to be working on a 60-degree reference angle, or a pi over 3 reference angle. In the second quadrant, of course, that's going to be 2 pi over 3. So initially you'll have x equals 2 pi over 3, and then in the third quadrant, where it's also negative, you would have 4 pi over 3. We're not going to write the general solutions just yet. Okay. Now we'll set that cosine of 2x equal to 0. So the cosine of 2x equals 0, so we can temporarily let u equal 2x. So this would turn into the cosine of u equals 0. Well, where in the interval from 0 to 2 pi does the cosine equal 0? Well, that occurs at both pi over 2 and 3 pi over 2. Alright, so let's start with the general solution of the first factor. So, unfortunately, both of these are going to be their own factors, and they're both going to be plus 2 pi because cosine has a period of 2 pi. So you'll start with x equals 2 pi over 3 plus 2n pi, and then you'll get again at 4 pi over 3 plus 2n pi. And of course, if you put these in, you would end up getting a 0. So both of these answers are going to check out. Now, isn't it true that if you take pi over 2 and add pi to it, you'll get 3 pi over 2? So in general, to start with, you'll have pi over 2 plus any integer multiple of pi would be your general solution. So you would get pi over 2 plus n pi. However, we're not done yet. We have to put in 2x for that u, so you would get 2x equals pi over 2 plus n pi, which then if you solve for x, you'll get x equals pi over 4 plus n pi over 2. And if you put this in, put in that multiple of 0, you would just get 2 times pi over 4. That would give you the cosine of pi over 2, which is 0. If you put in 1 for your integer, so pi over 4 plus pi over 2, that's going to end up being 3 pi over 4, which would give you the cosine of 3 pi over 2, also 0. So that solution checks out. So you have 3 general solutions. X is going to equal pi over 4 plus n pi over 2. Then it's going to equal 2 pi over 3 plus 2n pi. And then it'll equal 4 pi over 3 plus 2n pi. So these are your 3 general solutions to this particular equation. Now I just got 2 more for the lesson, and they're both quadratics. So we will go ahead and solve those real quick. Alright, so we have 2 times the sine squared of 2x equals 1. So 2 times the sine squared of 2x equals 1. Well, start out again, let u equal your 2x. So always substitute that first. Let u equal 2x. So this would temporarily turn into 2 sine squared of u equals 1. So now you'll have sine squared of u equals 1/2. And since this is quadratic, we'll take both the positive and negative square root of the right hand side. So you would end up getting that the sine of u is equal to plus and minus 1 over the square root of 2. So we have both roots considered, so this is going to be in every quadrant. So what gives me a sine of 1 over the square root of 2? A sine of a 45-degree reference angle. So that would be a pi over 4 reference angle. So you could start with u equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Every multiple of pi over 4 in the interval from 0 to 2 pi will give you 2 sine squared of u equals 1. Now, remember how we talked about in general that pi over 4 is the only angle you can actually add pi over 2 to and get the very next one. That's the only time it actually works. So you could list all this actually as one general solution of u equals pi over 4 plus n pi over 2. Alright, so that's your general for u, but we're not done yet. We need to put that 2x in for u. So if you put 2x in for u, you'll get 2x equals pi over 4 plus n pi over 2. Now we just solve for x. You'll get x equals pi over 8 plus n pi over 4. Which, let's just test it real quick. So 2 times, if we had a 0 for the n, 2 times pi over 8 is pi over 4. So yes, that's actually going to work out quite well. If we put in 1 for the multiple, then you would end up getting, add 2 pi over 8 to that, you'll get 3 pi over 8. Well, 2 times 3 pi over 8 is 3 pi over 4. That's going to work too when you square everything. So yes, this solution checks out. So you can write all this actually as one general solution of x equaling pi over 8 plus n pi over 4. One more problem, which is a quadratic, and then we're done with the lesson. All right. We have that the tangent squared of 3x is equal to 3. So we're given that the tangent squared of 3x equals 3. Okay, well, start out, let u equal 3x. So we will let u equal that 3x. So this will temporarily turn into the tangent squared of u equals 3. Well, we got to take both plus and minus the square root of the right-hand side since this is a quadratic, so you would end up getting that the tangent of u equals both plus and minus the square root of 3. So that means, again, we're dealing with every single quadrant since we have both roots. So let's just temporarily list out all the solutions for u in the interval from 0 to 2 pi. What gives you a tangent of the square root of 3? Well, that would be based off of a 60-degree reference angle, so it'd be multiples of pi over 3. So you'd have pi over 3, 2 pi over 3, 4 pi over 3, and then you'll have it again at 5 pi over 3. Okay. Well, we know the period of the tangent function is pi, isn't it? So if you wrote u equals pi over 3 plus n pi, that's also going to cover the 4 pi over 3. So both of those are covered under this one. And then if you took that 2 pi over 3 and added n pi to that, that'll also cover 5 pi over 3. So we can start writing these as two general solutions. Now, the fun part's going to be when we set the 3x where the u is. So that would mean 3x equals pi over 3 plus n pi, and then you would have 2 pi over 3 plus n pi. So divide everything by 3, you'll get your general solutions for x. So x would end up, Why did I write pi over 9? I jumped a step ahead. That will end up being it, but I jumped a step ahead. You would get that x equals pi over 9 plus n pi over 3. And then you would end up getting 2 pi over 9 plus n pi over 3. So those are going to be your two general solutions. You'll have x equals pi over 9 plus n pi over 3, and then 2 pi over 9 plus n pi over 3. Alright, so that's it for solving multiple angle equations. The next lesson we're actually going to get into sum and difference formulas for trig functions. As far as like if you have the sine or cosine, any trig function of a quantity that's a sum or a difference. So I hope everyone has a great day. Take care.